Okay, we're back in the shop, and as I promised you guys, we're going to do a little hardening on these bits that we made. This is one that I made. It's a quarter inch square tool bit. Same process as what we used for making this hex one that is now mounted in my drill. So what we got here is a little acetylene torch, oxyacetylene, and I found a new use for my micrometer holder. It also will hold your torch very nicely. So what we'll do is get the torch running. We're going to run a slightly carburizing flame on here so that we don't pull any carbon out of this tool steel that we want to keep, and that's what gives us the hardness. As I said earlier, this is W1 drill rod. I've got my little water bucket here ready for the quench, so we'll light the torch and we'll gradually bring the tool bit into the flame and try to get maybe the first quarter inch of that tool bit cherry red. And once that's accomplished, we dunk it, and that will give you a very, very hard tool steel on the end, to the point that it's brittle, and then we'll do a little tempering to bring it back, and I'll show you how we do that. So here we go. As you can see, I've got couple of cones there, and that's what we want. We don't want a sharp defined cone, because that would be a neutral flame. This is carburizing, so we're going to enter the flame and start the drill. As you see the coloring starting to pull back, pull out of the flame. Starting to get that color. I got a nice cherry red there. Into the water we go. That takes care of that one. We'll drop this one somewhere where it burned. I think I'm going to bring up my heat a little bit. There we go. Now this is quarter inch square. There we go. We're at cherry red. Into the water we go. Shut the torch off. And as I dunk it, I kind of swish it around. There we go. Okay. Now you can see, let me see if I bring you in here. Focus in on that. This line here is what you're looking for when you're trying to get just the forward quarter inch of that bit hard. And right now that is very, very hard. If I take a file to this piece, it's just going to slide right over. I've got a brand new mill file here, and you can see that that just slides right over. That is really, really, really hard. but it's so hard that when we try to use it, it'll start to crumble on us because it's very, very brittle. The grain structure is so brittle in there, and that's useless. We don't want that. So what we need to do now is polish up the steel using one of these little buffing pads here. Let me switch to autofocus so we can get you guys here. Now you can see that this has got that coloration. So what you want to do is get this back to a bright steel color so that when we do the tempering, we'll be able to see the shadow line from the tempering process. And once we see that straw color come into play, then we back off. And this is what you want to accomplish here. You want to get that metal brightened up again. Let me get into the focus zone here. Come on, camera. All right, there's a slightly buffed up finish, and you can see these are dark, haven't been done. So I'm going to finish this up off camera, and once they're cleaned up and polished up, I'll show you how I do the tempering. Okay, I've got the pieces all cleaned up, and you can see that I polished them up so that you've got a bright, shiny metal showing. You need to do that in order to see the heat treat line. And what we're looking to do is to bring this end of this very, very hard steel back in a process called tempering. Now, some folks have asked me, well, what's the difference between tempering and annealing? Annealing is when you take the entire piece and bring it above its critical point where the crystal structure starts to alter, and then you take that, and it's usually somewhere in the cherry red region, and then you would take the piece and put it in some kind of insulation, either like lime or glass wool, something that can withstand the temperature, and let it cool very, very, very slowly. What that does is it brings the material back to its softest point. Now what we did is we heated this up to the critical temp, which is that cherry red temp, and dunked it in water. That causes that crystal structure to form that's very, very hard, but also very, very brittle, which we don't want. So now what we're going to do is we're going to add a little heat very gradually, and this is something you got to be really patient with, because the heat treat line that'll show up in the part happens very quickly, and you've got to be watching for it. So let's give it a shot, see how we do on this one. Now you guys watch, hopefully I've got this in focus. Watch the tip of the piece. I'm going to bring it in very gradually into the heat, but not into the flame. I just want to get as close to the edge of that flame, and watch for that straw color to start to show up. And when it does, it really moves fast, so you have to keep your eye on it. You don't want to rush this. Trying to inch in a little bit more. We're almost there. I can see some color showing up on the tip. Now normally this would be done in a tempering oven at about 500 to 600 degrees. But I don't have that. You just got to be patient. Sneak in a little bit more. Like I said, you don't want to be in the flame. Okay, you can see it starting to creep from the tip, and it's working its way back. You can see that faint line. So what we got to let happen here is let the heat transfer backwards into that metal. And the line we're looking for is a straw-colored line. That's about maybe a 1/4 inch back from the end. When that happens, we're going to dunk in water. Now you know why they have heat treating ovens. Like I said, you don't want to rush this because you mess it up really quick. Okay, I'm starting to see some straw on the flats. And that's it. We're right about there. Into the water we go. Give you a focus on here, and here's that straw color I was talking about, right about a 1/4 inch back, not at the end, but right here. So we've tempered this tool so that it's not as hard as it was. Let's do the other one. The other one's going to take a little more heat because it's got more metal to it. I'm in the flame a little bit there. You can tell, whoa, I kind of rushed it. I could see the line going back. I want about a 1/4 inch of straw back, and that's it. There you go. There you can see very nicely that straw color I was telling you about a 1/4 inch back. Now at the front, we're a lot softer than we were when we were at the cherry red stage and we quenched it. But if you take a file of this now, you'll see that the file still does not bite that. So it's still hard, but not brittle. And that's how you heat treat your tool bits. You can do the same thing with center punches and so forth, same process, although oil works better for that. Now this is water W1 steel, which is a water quench. All right, hope that makes sense. I'll bring you back afterwards and we'll do a test run with the broach fully assembled on the mill, and we'll make some test holes just to show you how well that tool works. All right. Okay, we're back. Sorry about that. Battery died in the middle of the clip, so had to take a second to change the battery. Hopefully I can edit that out. All right, so we're back to taking down this this hex to size. All right, let's take a measurement. Two 535. We got another thou to go. I don't know about you, but I'm getting a little tired of doing this. So we're gonna go for the gusto. We'll take a half. Screw it, let's do a 1. There's 1 thou. See where that put us. I like to do a couple of different flats. All right, I think we're going to call that. I got 253. I mean 2528 on there. Hopefully you guys can see that. 2528. So that takes care of that. So now we're at size. Okay guys, this is the brooch we just finished, and I just made a little plate here with 3 holes in it, and that's a 1/4 inch hole with a countersink. So we'll now demonstrate the brooch that we just made. You just keep a steady pressure, don't push it, let the tool do the work, and there's 1 hole. Now on the way out, same deal, just let the tool do the work. Now we'll go to the next hole. Now this is a through hole, so you don't have to worry about chips. They're coming out in front of the bit. Nice and steady pressure. You can feel it going down. You don't want to push it. Give the tool a chance to do its work. There you go. And 1 more. This is 1018 steel. See if we can get you a shot of the close up here. If our 1/4 inch wrench fits in there. There you go. Very little play in that. Some of the other ones are a little tighter that I made. Beautiful. Let's see if I can focus in on that for you guys. See the nice flats. Now if you want a really nice, you do both sides of the plate with the chamfer. You can see that chamfer just makes it, gives it a chance to get started. Same thing on the other side. That's where we started from. All right, so there it is. The tool completed, and there you go. Nice. So that's it. If you have questions, leave them in the questions section. Thanks.